In last video, we looked at the capacity factors in the clause 2.3 in table 2.1 and table 2.2. Table 2.1 is applied for members and table 2.2 is applied for joints. Now look at the K1 and K4 in this video. Now for K1, I have put some notes here. Now the K1 is denoted as is referred as a duration of load factors, and duration of load factor is given in this table 2.1, and thus clause K1 here on clause 2.4.1 it has duration of load. These factors applied a penalty to the long-term factors. Penalty means you have a reduction factors, like it will be less than 1. Now it can be referred either table 2.3 or it can be referred table G1, which is in the appendix G, which will have a more detailed discussion rather than just the durations. It is based on your load combination. So if you have different load combinations, 1.35 dead load, you will have these solid timbers or joints, you will have these factors given here for the various scenarios. It is for this scenario also. So mostly we're going to use table G1, but it can also be used for table 2.3. Now there is one critical note that I like to read here. That note is given just before on page number 20, just before that table, that the critical strength limit load combination may not be the one with the highest value because of the resistance of the timber to the load is a function of duration of the load. So what does it mean? Say like if you are designing for steel members or concrete members, we are working with the let's say 1.2G and 1.5Q was give us the ultimate load, but here we will have these K1 factors will be different combinations. For example, 1.35G, look at that K1 factor 0.57. so it may go on these factors 1.35G. so yeah, in these timber designs you need to work out your design for 1.35G, 1.5G. so all the load cases need to be checked independently, because your K1 value is different for different loading case. It's not like that always you will have this is the highest load, meaning that you will have the your design will govern by this load case. It would be governed by 1.35G, although this load is less than this one, but this factor is less than this factor, so this may govern your design. So need to check all the load cases in that case, which is the K1. Now moisture content was simple to just read it from the tables. Now in the moisture content, which is given in the clause 2.4.2, that is just over the page, you will have this moisture content clause 2.4.2. there are three clauses given for this one: general 2.4.2.2 for on-season timber, and that is the for season timbers. It all again apply the penalty to the season timbers in moist conditions. So if you have a season timber, and if you putting that season timber into the rain or close to the beach houses, then you will have a penalty or benefit to the small on-season timber that is allowed to dry. So if you have a on-season timber and the small one like 38 millimeters, it will be advantage for you. So if you have a season timber and it's sitting on to the moisture condition, you have penalty. You will take an advantage of on-season timber small members, you will get these factors more than 1.15, so that is good, but it will not going to apply any penalties. So let's talk about the on-season timber first. So on-season timbers, that is clause 2.4.2.2, it does not include the LVL grades, so please consider this clause is not applied for LVL grade. We will talk about LVL grade later. K4 value is read from table 2.5, but there is a conditions. The condition is this one here, that on-season generally is taken 1, where on-season timber is used under the normal condition of temperature and humidity and will not be subject to its full design load until the partial season below 25 moisture content. It permissible increase the characteristic capacity of on-season timber by multiplying these factors. So if you have let's say it's talking about when your member is sitting during the constructions, like let's say it does not go to the service, and during the construction it will dry out quickly, right? It will dry out quickly, meaning that the standards take an advantage of that factor, that if you have unseasoned timber which has a lot of moisture in it, but if you are putting that one during the construction in the exposed to the environment, it will dry out quickly. So that unseasoned timber, if you have smaller cross sections, you will have these higher factors. If you are using 100 millimeters member, there is no any advantage of that one. So smaller unseasoned timbers is the advantage, that K4 value increase the moment capacity. Let's say seasoned timbers, that is given in the clause 2.4.23. Let's talk about the seasoned timber. So seasonal timber is K4 equal to 1, that is given here, unless your beam is subject to the condition in which the average moisture content, okay, average equilibrium moisture content, that is stand for EMC. EMC stand for average moisture content for a 12-month period may exceed the 15%, in which case calculate this. So what does it take? You can take 1, but if your seasonal timbers, like season timbers, if is exposing into the rain, let's say unprotected rain, if you have beam sitting into the outside of the house and it exposed to the rain, then you need to use this K4 value between these two. If it is subjected to ocean, so if you have a beach house and you have timber members in front of that ocean, then you will have a high moisture content coming from that ocean. So you need to use these maximum of these values up to that 0.7. And exposed timbers in a bathroom. So if you are designing something timber, let's say roof timber or some members that are exposed to the bathrooms, would have exposed to the steam. So in that case, you need to take K4 value of this one. Otherwise, you take 1. Okay, if you have an internal seasonal members which is not exposed to the environment, where moisture content, meaning that if your moisture content does not increase by 15%, every timber has his moisture content. The moisture content should not increase 15% over the period of 12 months. Then you take this K4 value equal to 1. If it is more than 1, more than 15%, you will take this K4 value. For LVL timbers, again you will have same condition, K4 equal to 1, and there is a table 8.1 where you can read that value. I can show it to you here in the table 8.1. There you go, table 8.1, they are talking about this moisture content factors for LVL, and for bending and compression is almost same value that you are seeing here. If you do the calculation maths, you will get the same value. And these are two different value for tension and shear and material for elasticity. So based on various equilibrium moisture content, you will have various K4 values given here. As you can see, less than 15%, meaning that your seasonal timber is not sitting outside. It is not exposed to the rain or ocean spray or bathrooms. Then you will have this one. But if you have your seasonal timber sitting outside, you will apply these kind of penalties to your design. I think in the next video we will talk about the next factors. Thank you.